17. We are going to test your auditory skills, meaning how well you can listen and follow directions. On your piece of paper, here's what you need to do. Individually, without talking, you are going to select one option from each list that I give you. Pair that I give you. And you need to write down your selection. Are you ready?
No.
Don't ask questions. Just write down your answer. Chocolate or vanilla?
Vanilla.
Shh, write it down. Don't talk. Hot dogs or hamburgers? Sun or moon? Black or white? Skittles or Starburst? Bus or Max? Summer or winter? Ice cream or cake? Now, your job as a table, A, make sure you know each other's names, but B, you have to decide on the correct answers, and there are correct answers. Okay, trust me, there's a pattern. You're looking for the correct answer. So you can share which option you chose in your table, go through and make the list for your entire table. So your table is now going to have a separate sheet of paper. I'll hand you some scratch paper, and I need your list from your table that all of you agree on. All of you agree on a separate list. Yes?
There are right answers, but are there wrong answers?
Yeah.
Oh. Well.
Okay. I'll give you scratch paper. You guys have 3 minutes to come up with your group list. Okay. We are starting a new section of our notebook. So just like we did last time, you're going to have your progress sheet. Whoa, whoa, whoa. Where are we?
Oh, man.
Sorry, you'll be all right. Did I hit your finger? Sorry, dude. Okay. What's happening?
Why did I do that?
If you're really fancy, you'll make it so your tabs are not only lined up, but about the same distance hanging out from the book. On this tab, I will be writing A3 systems. Right, so you're trying to get that in there. And once that's in there, you also need to know the page this is on. Okay, the page number it's on, so you might need to write some page numbers if you haven't been writing them. No, care. Page numbers? Anthony, do you have your page number? What page are you on? Yeah, liar. Go ahead and add that in there. My A3 systems. Add it to your index. I'm on page 71.
Oh yeah, because you also do lesson plans.
Because no, my notebook should look exactly like yours.
Oh yeah, that was
Just saying. If you're done, you can go ahead and preemptively start numbering your pages.
So how do you get sticky
Sure, we have sticky notes.
You didn't get one?
I give two.
Are you okay?
I've been kind of the rest of it. So, moving on. Here's the deal. You should have index, tabby-do, progress sheet, done. Okay? If it's not done, then you can go ahead and do that quietly on your own. We are talking about A3 systems. We have been solving systems, and now we're going to start to use some of the official, take it off your face. We're going to start to use some of the official methods and talk about it a little more specifically as we get into it. Okay? So, first off, we're going to write down 2 of the ways that we have been solving systems, just formally. Okay? Of course, we're talking about A3, which is systems. The definition here okay, let me give you that definition first. A system of equations consists of 2 or more equations. Alright, so a system is when you have at least 2 equations. And we talked about this a bit on Friday, that you can have a system of just 2 equations. You can also have systems of 3 equations, which you guys are going to see. 4, 5, 6, 7, etc. And as you get into more and more complicated systems, that starts to be called linear programming, which you don't need to know just yet. Okay? Yeah, what's your question?
So based on how our last test was, where it was testing us on both A2 and A1, is that how the rest of the tests are going to be for the year, pretty much? So like through the semester, it's going to be more and more sections or subjects.
Yeah. So they're going to be building, but here's the deal. I'll just tell you this already. Systems is just a combination of A1 and A2.
Oh.
Okay? A2 was graphing. A1 was solving. Systems is graphing and solving. Okay? A4 is really just the same thing as A2. This semester is all really, really interconnected. Okay? We just are going to keep building with the same ideas.
So
Arcane, don't be rude. The next semester will be interesting. Yeah. Okay. So what we're dealing with here, we're going to be talking about solving systems. And to solve a system means to find when all equations are equal. We're trying to figure out when are all the equations equal? Or, in other words, when are all the equations true? What numbers make all the equations true? There's one way we know how to solve systems. It's to solve by graphing. As an example, if I have the system y equals 4x plus 3 and y equals negative x minus 2, right? 2 equations in this system of 2 equations. And I want you to solve by graphing. Pretty straightforward. Anthony, figure it out. Okay? One way, yes, I know that we could all get on our calculators and do that. But right now I want you to work on solving this by graphing. Graph both of these by hand. Okay? So make an x and y axes, graph these 2 lines, and see if we can't see the system of these equations. Or I'm sorry, the solution to this system. Okay, so all you're gonna do is graph those two lines on the same graph, the same set of axes. So go ahead. You know how to graph where they start, how they're changing. Graph two lines. The quicker you're done with this, the quicker we move on. Line. Oh, this one. We'll say this is the blue line. Right? Where does that graph start? 3. So that graph starts at 3, and then it goes up 4 over 1. Another way you could write this, as 4 over 1 x plus 3 if you wanted to. Because it's going up 4, 1, 2, 3, 4 over 1. Okay, it goes up 4 over 1. So that when I graph it, there is my blue line. Okay? So making sure it's going up, that you didn't draw, your graph should be pretty steep. A slope of 4 is pretty darn steep. Okay? And I would do the same thing for my other line. Right? This one over here starts at -2 down here and is going down 1 over 1. That's a slope of -1. This is a slope of -1 over 1. So it should be going down. So if I graph this line, that's what it looks like. And the question is, where do those two cross? Boom, right here.
Wait, what? I was still right? How was I still
-1, -1 is the solution. Okay? That would mean -1, -1 is the solution. And here's how we check. Because guess what? I'm going to be asking you to check. Because I don't care if you're wrong, but you need to know that you're wrong. Okay? You must know when you're wrong. In order to check, we are going to plug -1, -1 into both equations. This is crucial. You must check it in both equations. -1, -1 is only the solution if it works in both equations, if it makes both equations true. Now here's the deal. Some of you are choosing to check out right now, and that means I'm going to have to spend longer doing this. Okay? I would love it if I could just give you the essentials and then we can go. But guess what? If you don't have the essentials and I have to keep repeating this process, it's going to get increasingly boring. So, Yahi and Arcane, I need to make sure that you have stuff written on your paper. It is not an option to just sit there and be rude. Okay? Not participating is rude. Alright? So, I need to plug -1, -1 into both equations. We know that x and y. My first equation, I'm going to check both of them. The first equation is 4x plus 3. So I'm going to plug -1 and -1 into both of those just to double check. I should get a true equation right here, right? -1, -1 should make that equation true. Okay? So when I plug it in and I multiply, 4 times -1 is -4 plus 3. And of course, if I look at -4 plus 3, I get that that is indeed -1. So -1 equals -1. That's a true statement. The check worked for the first equation. Just plugging in your points into the first equation. And then I would do the same thing with the second equation. Okay? You just take -1, -1 again, plug it into the pink equation, making sure that you get a true statement. You get two numbers that are equal to themselves. Both equations, there was my first equation. Here's my second equation. When I plug in -1, be careful with this negative sign, because that's where you guys are going to mess up. Is usually on the negative sign. Some of you guys did that on your test. You messed up your negative sign real bad, and then when you checked it, you just kind of pretended to check it, and your check wasn't real, and you pretended like you checked it and it was correct, but you were still wrong. Bad spot to be. Okay. -1 times -1 we know is +1 minus 2. 1 minus 2 is, of course, -1. So I checked it. It's correct. I'm done. Okay. Now, we've already talked about graphing, and you also know that you can graph using your graphing calculator, and that would probably be the preferred way. But there will be times that I ask you to graph by hand. We need to make sure we have all of them. Okay? The more tools we have, the easier this is going to be. Okay. So we are going to talk about one more. We're doing one more example. We're not even graphing. Okay. Here's your next example. We know how to solve by graphing. We can also solve using substitution. Yahi, I know I already heard you say that. It's called substitution. You already know how to do it. You've already done it. We're just calling it its formal name. It's called substitution. As an example, if I wanted you to solve y equals 5x minus 5 and y equals negative 6x plus 6, by substitution, what would I do here? Yep, set them equal to each other. Now, you already know how to do this. We've already talked about it. I'm just asking you to do one more example. The first step is to set the two equations equal. Essentially what I'm doing is I'm saying, hey, this, what's negative 6x plus 6 equal to? Look, real quick. What's negative 6x plus 6 equal to? No. No. What's it say? It's equal to y, which is why, I can take this and I can substitute it in. That's really what we're doing when we're saying it's equal. We're substituting this in for y. So if I was trying to say my two equations are equal, I would have this. 5x minus 5 is equal to negative 6x plus 6. And now that's the equation I'm solving. That's the equation I'm solving. So go ahead, all of you right now can solve that equation. Okay, solve that equation. One side y's to, or numbers to the other. First step is going to be to add the 6x over to this side. 5x plus 6x is 11x minus 5 is equal to 6. What's my next step? What? Lorenzo, what do I do with this? Add 5. Add 5. I get 11x equals 11, and when I divide by 11, I know that 11 divided by 11 is 1. Yay. Okay? So x equals 1, but, right, the solution is a point. The solution is a point, is an x and a y. It's an x and a y. So, if my first step was to set the two equations equal, my second step is to plug in x to solve for y. I can do that in any of the equations because if, ultimately, when I plug in x into either equation, I should get the same thing. If you don't get the same thing, you're not right. Okay, x would not be correct. So I need to plug it into one. Choose an equation, top or bottom.
5x minus.
Anthony, is that what were you gonna say? He was raised his hand.
I always raise my hand before me.
The second one, he's just doing that just to tick you off. So I'm gonna in the second equation. In that equation, I'm plugging in 1 for x. When I plug in 1 for x, negative 6 plus 6. Negative 6 plus 6 is what? 0. I got negative 6 plus 6 is 0, which now means that 1, 0 is the solution. That would be my answer. But before I could totally know for sure 1,000% that that was my answer, how do I know I'm right? How do I know I'm right, King? Yep. To what? No. Plug it into what? We're talking to King. We wrote it down. It was on that last page. I wrote it. I said it. To check. I do what? Kane? What do I do? Oh my gosh. Plug it into how many of the equations? Both. Don't say one of. Plug it into both of the equations. Both of the equations. Okay? So that means I need to plug in the point 1, 0 into both of my equations. Right? So if I'm really checking, my check here would be into both equations. First equation, y equals 5x minus 5. Plugging in the x and the y. I get 0 equals 5 minus 5. Is 0 equal to 5 minus 5? Yeah. Tanner, don't be distracted. It checks in one equation because our king can't handle it. Plug it into one equation. Check the other equation. Negative 6 plus 6. Plug in 0 and 1. And you should get 0 equals negative 6 plus 6. 0 equals 0. It is true in both equations. The point 1, 0 makes both equations true. That's my full check. I will never, ever, ever give you a substitution example ever again. Okay? If you don't have this one example written down as your reference, then you're not going to get another one ever again. Because guess what? I'm not doing this again. Okay? From now on, if I say, hey, use substitution, and you go, I don't know how to do that, I'll say, where are your notes? And some of you will say, I don't have any. I'll be like, well, it sucks to be you. Okay? If you don't have your notes, I'm not helping you. Okay? This unit, just so you know, thanks. You can say that again before I have to say it. Yahi, wake up. Yeah. Okay? This unit, I'm just going to warn you right now, is one of the most algebraic. There's a lot of methods. You guys, by the end of this unit, are going to have five different ways to solve systems. Six different ways to solve equations. You are going to be responsible for 5 of them. I won't make you show me guess and check, but that is one way to do it. Okay, now, here's what we're going to do. Okay, you should have a paper.
Can I hit people?
No.
I don't want to die.
I wish not to die next to the money.
Put it on his milk.
Actually,
Okay.
To tell me how long a penny and how long a paper clip is.
5 years.
Ooh. Yeah, I know you don't have rulers.
I got this.
The instructions are on your page. You may not use rulers. Why we took them. Okay. The instructions are on your page. You need to read them. You're working. Actually, I'm going to have you work in pairs. I don't want you to work in fours. You're going to work in pairs.
what about apples? Why do you think
Then someone's going to work individually. Some of you are getting to a spot where you don't feel like you can solve this. So I'm just going to give you a quick example that may or may not help you in your task. Okay? So I would like you to again write this one example down.
In our books?
In your books. Okay. Another way I could solve this another way to think about substitution. You'll notice this problem is different from my other problem, right? Because, no, they all have two variables. If you have two equations, you're going to have two variables. So, these guys, if I looked at our first example that we did, they were both equal to y. They were both equal to the same thing. The problem with this next example, and the same problem you guys are having with your pennies and flips, is that this x and y are all jumbled up. It doesn't have just a y by itself. But here's what I can do. There's really two options. One option is I could solve this equation for y. I could take that second equation and I could solve it for y. Like I said, the option of if I wanted to graph this, I could solve it for y. I could put it in slope-intercept form. I could move the 2x and I could divide by 3. That's one option. Another way you could think about it using substitution, and Ansel was saying the problem is that there's two variables right here. I can only solve an equation that has one variable. So, if I look at this, what's negative 6x equal to? Y. That means I can put it in for y. I can substitute it in because they're equal. They're interchangeable. That's what substitution means.
So would that be a negative 18x?
So this would be this. I would have 2x plus 3 times negative 6x equals 32. And now I have just a regular equation that has just x's in it. So now I just have this, 2x minus 18x equals 32. I can go ahead and simplify that to be negative 16x equals 32. And then I could finish solving. So that's one way that it might help you substitute. It might help you. Again, there are other options. You could, okay, I was talking about that you could take this second equation and you could solve it for y. You could turn this into something that looked like y equals whatever it is, negative 2/3 x plus blah blah blah. You could turn it into something like that and then do our first method. Or you can just get one equation for c. You could solve one of your equations for c and you could plug that in. Or you could solve them both for y and graph on your graphing calculator. Okay? But you do need to use one of them probably. Okay? So let's see if in 3 more minutes you can't each have the actual length. Okay, cool. So, you should have had paperclip and pennies. What was the first one? The first one is 1 paperclip and how many pennies? Cool. Was 11 inches. That's your first equation. Your second equation, 14 here. That's okay if you had 14. Okay? The second equation was 2 paperclips plus 8 pennies is equal to 8.5 inches. Those should be the two equations we're working from. Okay, those are the two equations we're working from. The problem is, right, I'm just going to write these again. C plus 13p equals 11, and 2c plus 8p equals 8.5. Now, it'd be really nice if they weren't all jumbled up, if the c's and p's weren't on the same side. So what I can do is I can take this first equation and I can make it so that c is by itself on one side. I can rewrite this equation so that c is by itself on one side. If I'm trying to rewrite this equation so that there's only c on that side, how do I get rid of the negative, or giveaway? How do I get rid of the 13p? Yeah. Move this to the other side. So that I have this. C equals 11 minus 13p. And so I have that equation, and I still have my other equation. Some of you might be tempted. You might say, oh cool, I can just do the same thing for my second equation. If I just solve my second equation for C, then I can put them both equal to each other. That's one way. Or you can say, oh cool, I know what C equals. Right? What's 11 minus 13p equal to? It's equal to C. And so if it's equal to C, that means I can take this and I can plug it in. I don't even have to solve both equations. I can use substitution to take my first equation and plug it into my second equation. So if I plug it in, I want everyone right now to write that down. Write what it would look like if you plug that in. I'm not going to write it for you. Lorenzo, awesome. Write it down. What does it look like if I plug that in? Everyone should have it written down. Rewrite this second equation. Instead of C, you're plugging in 11 minus 13p. So you should now have an equation that has no c's in it. You should have an equation with no c's. Do you have an equation with no c's?
I have 26 minus 26, or 22 minus 26. 2C and C equals 11.
Right, again, please double check. When you plug this in, when you plug that in, the C is, I'm not writing the C anymore. I'm plugging in 11 minus 13 in place of the C. Hey, don't talk while I'm talking. And then I still have the rest of my equation. Plus 8p is equal to 8.5. Okay, that's my new equation. This is the equation I need you to solve. That's the equation I need you to solve. Now here's the deal. That is the rest of the hints I'm giving you. When you think you have the actual length of one paperclip and one penny, you can come show me and I will be giving you your homework.